Have you ever wondered what acid will dissolve flesh the fastest? To find out, I get started by cutting a piece of steak into roughly same-sized pieces and then put them into 6 separate beakers. For this experiment, I decided to test 5 of the acids I use most often at their maximum reasonable concentration, along with some lye for fun. To that end, I add a solution of cold 32% hydrochloric acid to the piece of steak in the first beaker, a 40% sodium hydroxide solution to the second, 100% acetic acid to the third, 98% sulfuric acid to the fourth, 70% nitric acid to the fifth, and 85% phosphoric acid to the sixth and final beaker. Upon adding the acids, it seemed like nitric acid and hydrochloric acid did the most immediate damage, causing them both to become discolored as if they were cooked. The sulfuric acid sample started to show visible damage within a minute as the piece began to darken and shrink due to exposure to the strongly dehydrating acid. The phosphoric and acetic acid samples darkened last, and it seemed like the acetic acid pulled some pink color out of the meat somehow. Sodium hydroxide being a strong base is the outlier here, and interestingly enough, the lye seemed to make the red color of the steak much more vibrant and didn't really cause any immediate visible damage. After allowing the pieces to sit around for a while, I decided to put them on the hot plate and bring every sample up to 65 degrees Celsius to try and speed up the process. In the lye beaker, this quickly caused all the fat to quickly saponify, leaving the steak a very uniform red color. The fat also disappeared from the hydrochloric acid sample, but I think it was simply melting rather than dissolving. Next, I heated up the sulfuric and nitric acid samples, and these were by far the most dramatic. Within a few seconds, the sulfuric acid piece began to blacken and dissolve as the meat was quickly dehydrated to elemental carbon. Nitric acid took a lot longer, but at a certain point it began bubbling in much the same way that metal bubbles when you dissolve in an acid, which is something I've never seen before in a biological sample. I have no idea what these gas bubbles were, but it was clear that unlike the other acids, nitric was the only one that was truly and actively dissolving the meat. I heated up the acetic and phosphoric samples last, and these were the least remarkable, as I expected. They both seemed to darken and shrink up a bit more, but that's about it. Anyway, at this point, I simply took every sample and set them out to sit overnight and continue reacting. Now, when I came back the next day after allowing the steak samples to digest in acid overnight, this is how the less impressive phosphoric, acetic, and hydrochloric samples looked. As you can see, they're all still very much intact and don't really look to be breaking down all that much. On the other hand, here are the more successful nitric, sulfuric, and lye samples that looked like this. No solid pieces survived the heating process in the sulfuric acid, and it's now just a sort of uniform black slurry. The color of the meat in the lye beaker is still remarkably nice, despite it now disintegrating and smells like horrid meat-scented soap. Meanwhile, the nitric acid is still slowly but surely bubbling away, dissolving the meat into a smaller and smaller chunk. When I came back again the next day, the lye had essentially eaten the piece of meat into a pink slurry. The hydrochloric acid sample looked a bit softer, and the acetic sample looked like it darkened a bit more. The phosphoric acid sample had seemingly taken the pink color out of the steak, and the nitric acid had dissolved it to a stringy mess. The sulfuric acid sample looked the same as the day before, and I'm pretty sure it's completely dissolved at this point. Now, after 2 more days, I decided to end this little experiment and began by dumping out the poorly performing acetic and phosphoric acid samples. They were both horribly discolored, but by no means had really dissolved much at all. Once I gave them a thorough rinse and dried them off, I found that the piece of steak that had spent 4 days in the acetic acid was incredibly tough and almost like beef jerky, while the piece that had sat in the phosphoric acid was still tough but repulsively slimy. Looking at the next 2 samples, which I'd like to think of as intermediate performers, hydrochloric acid really pulled ahead in the last few days and dissolved the piece down to a uniform, oily brown slurry. The lye sample looked the same as it did a few days ago and consisted of a lot of pink slime along with a large piece that was still mostly intact. I passed the hydrochloric acid sample through a coffee filter, which left me with this brown mess, and as for the chunk left over from the lye, it ended up being extremely fragile and broke apart easily between my fingers. The top performers, as expected, were nitric and sulfuric acid, but I will say I actually expected the sulfuric acid to win out. Shockingly, the nitric acid dissolved the meat completely, leaving absolutely no trace of oil, gristle, or odor of any kind. The sulfuric acid sample, on the other hand, was extremely dark, and along with the lye sample, smelled absolutely wretched. It did, however, completely dissolve the meat, just not nearly as cleanly and absolutely as the nitric acid did. Anyway, so yeah, as it turns out, nitric acid dissolves flesh more entirely than any other common lab acid, while sulfuric acid dissolves it the fastest and the cheapest. Hopefully this has been educational for you, and I do intend to make this a little series where I test these acids on a variety of materials, but I figured steak would be a good place to start. Follow to see more, and I'll see you all next time.